right? So this is how it will manage, right? So VAS will be managing a memory allocation for you, right? So you no need to directly allocate memory from the physical RAM. So you will just have to allocate memory from the virtual address space. It will take care of the memory allocation of your memory allocation in the physical RAM, right? So that is the reason, even though if you have same address in your individual or dedicated virtual address space, we no need to worry, because it know how to convert this 100 into available memory area, right? You can consider a memory object or memory area that we have in the physical RAM, right? So that is what here it meant to be, right? See here. So we have a virtual address space for notepad.exe, virtual address space for SQL server.exe. Let's consider, right? So we have, though we have, see, mm, though we have same address, it will be converted, right? It will be converted internally into different physical memory addresses, right? Memory area, memory pages, whatever it is, right? So this is how that works. Memory allocation will be through the virtual address space, right? So this you must be knowing, right? So if it is 32-bit 32-bit application or 32-bit Windows, especially 32-bit Windows operating system, so what is the so user mode space, and what is the so kernel or system virtual address space supported? So maximum of 4 GB. If it is 32-bit operating system, maximum 4 GB it will be supported. So in that 4 GB, 2 GB is for user mode, right? This is 32-bit. This is for user mode. This is for kernel, right? So this is user mode and this is kernel mode. We have 2 GB for user mode address, 2 GB for user mode virtual address space, and 2 GB for system, or you can consider it as a kernel, right? So this 2 GB is not for all the applications that we have. Let's say, for example, consider two SQL instances we have, right? So two SQL instances, two notepads, notepad and SQL, right? So this 2 GB, each and individual application can go up to maximum of 2 GB. This is the virtual, not physical. So virtual address space, it can go maximum of 2 GB per individual application, right? It is not this 2 GB is not for all the applications together. It is for individual application can go up to 2 GB virtual address space. Remember, this is virtual, not physical. So physical, whatever memory we have, that will be for all the applications. But if it is virtual, whatever we have a limit, 2 GB limit for 32-bit operating system. This is per individual application. This is also per individual applications that we have, right? This is not basically application wise, you can ignore that. So this is a total virtual address space at the kernel level. But the user mode, so we have multiple applications, each application can use up to 2 GB as a virtual address space, right? If we need more than 2 GB, so I don't like whether you heard or not, so we have something called 3 GB switch. So if it is a 32-bit application, 32-bit operating system, we have something called 3 GB switch. If you enable this 3 GB switch, boot.ini or somewhere we'll have to enable, because we don't have 32-bit, and uh, I have never done that. But yeah, 3 GB switch will have to enable so that it can go up to 3 GB user space, right? So how this another 1 GB came in? So another 1 GB will be stolen from the kernel mode, right? 1 GB will be stolen from kernel mode, and it will be allocated to the user address space, right? Now it will become 3 GB. This will become 1 GB. right? So this is how this works, the user mode and kernel mode. Okay, and this is so for example, I'm not going much into that, but for now understand that page pool and non-page pool. So what does it mean? Can anyone tell me, if you have idea, what is the page size in a physical, in Windows page size? So like SQL Server, we have 8 KB page. Windows also we have pages where it will be allocated memory. Whenever the page has to be removed from the memory, it will be going to physical area, right? So I will tell you which area it will be going, but anyone know what is the size of Windows page, or any idea, like, so how much it would be the page size for Windows?
Don't.
Yeah, Kiran, not sure.
Huh. Not
Okay,
sure.
no issues. Okay, so memory area will be 4 KB. Memory page size in Windows, it will be 4 KB, right? So if you have 8 KB page in the memory, that 8 KB will be converted into two different pages in the physical RAM or physical memory. So that will be 4 KB and 4 KB, right? So 4 KB memory will be allocated whenever it needs memory. I mean, let's say for example, um, Windows operating system needs more memory, right? Windows operating system needs more memory. Let's consider this scenario. This is your so Windows operating system, and where we have SQL Server installed, and where we have another application installed on this computer, right? Let's consider 5 GB, total 8 GB RAM, 5 GB allocated to SQL Server, and 2 GB, let's consider, allocated to, this is I'm talking in 64 operating system. So leave about 32-bit operating system, because we know more 32-bit so servers or architecture, right? So we are talking about Windows 64-bit architecture. I'll tell you, if it is 64-bit architecture, we were talking about. So we were talking about this VAS, right? Virtual address space, how much it will be for user space and how much it will be for kernel space. For 32-bit, I will tell how much it will be for use 64-bit, how much user space for 64-bit, how much user virtual address space for kernel space for so 64-bit. I'll tell you in a bit, right? For now, understand 5 GB we allocated to SQL Server and 2 GB allocated to some other application. Now we have left 1 GB to the Windows. Windows 1 GB, it is 1 GB we have, and Windows, it needs some memory, right? It needs some memory at the Windows level. Then what will happen? Whatever memory we have allocated, whatever memory we have allocated from the RAM, it will be trimmed, right? So it doesn't matter whether it is allocated for SQL Server or whether it is allocated for any other application, the RAM will be trimmed. Trimming is nothing but cut down the memory, right? So the memory will be trimmed. So whatever memory it is required for Windows, it will be trimmed. So if it is trimmed, where this memory will be moved to, right? SQL Server memory, if it is released, where those pages will be going to, right? So let's consider that we have lazy writer, and it is removed some pages. If lazy writer removed pages, where it goes to data file. But if it is removed from the physical RAM, where it goes to? So it should go to somewhere else, right? That is where we have something called page file. I don't know how many of you heard. So this is the page file where we have. So that is the reason whenever page file is growing or page file is, so increasing, this is the reason. So the memory we are moving from the pages we are moving from memory to page file, right? So whenever it needs memory, right, whenever the application needs the memory which is paged out, so this we call it as a paged out. Paged out is nothing but removing memory from removing pages from memory, and it will be placed into the page file. So that is called paged out. Pages are out of memory, right? So we call this as a paged out. So I will show you that, so how it looks like in SQL Server. You must have heard. So the memory pages are, the memory is paged out and reduce that memory messages and all. So let me see if I have that. One sec. Just I'll tell you that what I'm doing. So don't worry about it. I just wanted to show you those messages if we have. Okay. Using still using. Okay. So I'll show you that, so whenever there is a page out, so what messages, like what kind of messages that we see, so in SQL Server. Okay. If you go read error log. Okay. It is taking so much time. So we are using memory models we will talk about. Buffer pool extension. Okay. Okay, so I don't have at this point anything in messages, but I will reproduce that and will show you how it looks like, right? So we will discuss that and we will do some troubleshooting so that you will understand how that looks like. Right, so these pages will be removed from the memory and it will be placed in the page file, and page file will be keep on increasing if there is any memory pressure, right? So whenever this memory we require, and it has to read from the page file again, and it will be placed in the memory, right? So that is what we call it as a page fault. I don't know whether you heard or not. So page fault is nothing but reading memory from the page file, right? So reading memory from the page file. So there are basically two page faults. One is hard page fault and soft page fault. Soft. So hard page fault is nothing but reading memory from the page file. Soft page fault is nothing but, so whenever there is a memory required, so this memory will be removed from the individual application and it will be keeping in some other memory area, right? Internal memory area it will be keeping, right? It is not flushing into the page file, but we have some internal standby memory list. So you can consider that standby. So where the pages will be written. So while reading the pages from the memory itself, you called standby. No, you call soft page fault, but don't worry about it. Page fault. We never work on any of the page faults issues. But if you work on just so understand that what is page fault. If that is the case, we need to understand if there is any memory pressure or if there is any memory allocation is not configured or something. This is what it meant to be. Page fault. So there are two types of page pools. One is the memory can be removed from the memory. The pages can be removed from the memory to the disk. Disk is nothing but your page file where it resides. So I don't know how many of you already looked at. Just a moment. Let me system properties. Yeah. Um, advanced performance disk advanced, right? So this is see here where I went to go to the properties of this computer or this PC. So you can use advanced system settings. You can go to advanced tab where you can see the performance here, right? You can see the performance, and where you go here the settings. I'll just close this settings, and you see here the advanced. So advanced, and where you have the total paging file size for all drives. I have around 23 GB. This is because I have flushed memory from buffer pool to from memory to disk, the page file, right? So this page file you can allocate, restrict the page file size by just customize the size or system manage size. If you mention that system manage size, it will dynamically increase the memory or dynamically will allocate this pages, right? So it will be a dynamic allocation. No page file. If you don't want page file, then you can use this no page file, no paging file. So then that is not actually a recommended one to utilize, right? Page file is helpful to read the memory, read the so pages which are allocated already, right? So if we don't have a page file, then the pages which are out of memory will be destroyed, right? So whenever you need the same page again, the allocation should be from the beginning. That is the reason page file, if you have, the pages will be allocated to the whatever pages which are allocated in the memory will be moved to the page file. If you need the same page, it will be read from the page file itself. So instead of creating a new page and allocating a new page. So the other area also we have something called non-paged pool, right? We don't want the pages in the memory to be flushed, the pages in the memory to be removed. So this is especially for SQL Server. Let's consider if there is a memory pressure. Here we have two applications. One is you can consider anything like Notepad++ or Notepad or any other application we have. So we allocated to the SQL Server 5 GB. If there is a memory issue, why should I remove from SQL Server? I don't want SQL Server memory to be removed. This okay, you can remove other applications or you can just uninstall this application, whatever you do, but I don't want SQL memory to be released. So if that is the case, I will decide, I as in like SQL Server will decide whether my memory should be removed or not. I will tell you which property it will decide, but for now understand, if you don't want SQL memory to be released, we can have so restriction. I mean, so in other ways, we have locked pages in memory and large pages in memory that we will discuss in a while. Understand? If we don't want SQL Server memory to be released, so we can enable the configuration so that SQL memory will not be removed. The other application memory will be removed, right? That is what we call it as a non-paged. So we don't want the memory to be removed from the memory, pages will be removed from memory, right? So whatever memory we allocated for SQL Server should not be removed. We call it as a non-page pool memory. So in other words, like what is working set? I will tell you what is working set. This is this is your memory RAM, physical RAM. So in that, so you have virtual address space, SQL Server. So you have threads assigned, and this memory will be allocated, right? Where this memory allocated, whatever memory we allocated in the RAM, so it will be allocated in the working set, right? So working set is the memory address, memory area where the memory will be allocated. So where this can be visible to the Windows operating system. This working set will be visible to the Windows operating system. Whatever memory which is not part of working set, Windows cannot see that memory. You know what I mean? So if the memory is not part of working set, right, is cannot see the Windows. It is a visible memory if it is allocated in the working set. So it will not be visible if it is not part of working set. So that is the reason. Let me show you this. Okay. SQL Server start. I'll tell you. Test. Test SQL 2014. Test SQL 2014. Test 2014. Okay. New query. SP underscore read error log control T. Using conventional memory. Okay. New SP underscore read error log. Right. I'm just checking the memory model. So I'll explain that what is this. Just go to the properties. Memory. Let's consider 1250. Memory. Let's consider 1250. Right. So both I'm using the same. Now let's go to the task manager. Right. So task manager, Windows can see or Windows cannot see is how you will know Windows is able to see the memory, whatever we allocated. So this is through the task manager, right? So details, SQL Server, PID This is bit. Just a moment. Let me see new query. Hmm, new query. What? SP underscore read error log. PID is nothing but process ID to identify which SQL server is which one is our SQL server, right? So you see here there are two SQL server.exe, but we don't know which one is our so which version of SQL server, what is the so name of the SQL server. So this is the one process ID. It helps to identify this is for which instance or this is for which instance. The other way, you can just go to this location, open file location. You will have that if it is a 2012 or 2014, that you can identify that which version of SQL server, right? But it is the better way, like process ID you will have to identify so that you will understand which SQL server this process IDs belongs to, right? 1180 is for this one, right? So this is your this is your 2019, right? For 2014, read error log 1165. And if you see here, memory active private working set, right? So active private working set, you see here, this is just, it is showing 20 MB for the SQL server. This one, it is showing 298 MB. Let's restart both the SQL instances. You might think that, so I just restarted or I just started this instance. That is the reason it is not utilizing. It is not showing here, but let's restart both the instances at the same time. So my intention was, this is the main reason you should not check, you should not see the memory utilization of your process from the task manager. So I'll go much into so that you will understand in a better way. So what is your approach like when there is a memory, so high memory utilization, how you will go through, how you will look into? Anyone? So if there is a, let's say there is a memory issue.
Task manager are using some scripts.
Correct. So task manager, so you basically see this, like, so normally you see the memory utilization whether SQL server.exe is exist or not.
Yes.
Okay. Yeah, but this is not the, so the way that we look for memory. See here, so I started both the instances. It doesn't matter whatever it is. For example, 1212 is definitely for so SQL server 2019. Let me show you that. SP underscore read error log. See, 1212 is for 2019. So the other one is for this one, 16908. You see here memory utilization for each one. SQL server.exe, right? So you can consider both these two. You can consider any memory utilization we consider. So the second one is showing high comparatively, right? So doesn't mean that it is not allocated. So though we allocated memory for SQL server, it is just showing uh, less amount of memory, right? So in the task manager, so it is not showing much. If you go to the process, okay. is that? Console SQL Server. See here. So memory utilization is 64. This is for SQL 2019 is less comparatively, right? So doesn't mean that it is just utilizing 52 MB. So in some, I have seen, so cases like how it looks like, they have allocated, so 500 or 600 GB, and users are saying that task manager receive only, so 1 GB or 10 GB utilizing by the SQL server. So why that is the case, right? So why it is utilizing only this much amount of memory, whereas I have enough memory to allocate and enough memory allocated to the SQL server, right? So that is not the scenario. So I'll explain so that you will understand. So I told you, right? So this is the paged pool memory and non-paged pool memory. Paged pool and non-paged pool. The SQL Server 2019 is following this. It is not non-paged pool. So what does it mean? The memory we allocated in the RAM is not visible to the Windows operating system. So this is paged pool. So paged pool memory is only visible to the Windows operating system. So the one which I see high memory in the task manager is this 2014. That is not using paged pool, right? That is using paged pool memory, where Windows can see whatever memory we allocated to the SQL Server. So I will explain that. That is, I told you, right? Working set is the amount of memory area we allocated in the physical RAM, right? So I will not, I'll just, so walk through this. The working set of your process is the set of pages in the virtual address space, right? So set of pages in the virtual address space of the process that are currently reside in the physical memory. That's what here, right? So whatever virtual address space we are allocated, the memory which are allocated through the virtual address space, these pages will be resides in the memory. This is the memory area, right? We call it as a memory area. That is what resides in the physical memory. Contains only pageable memory. See the working set. I told you in the previous slide, pageable memory. Whatever memory which Windows can see, that is called pageable memory. Non-pageable memory that Windows cannot see, allocations such as AWE. So you must have heard. So address windowing extension, right? That is the different memory model. We will talk that later. Or large pages memory are included is in the working set. This working set, whatever memory we allocated through AWE or large pages, I will come to these 2 points after this. For now, understand, if memory is allocated from any of these memory models, then the memory will not be visible at the Windows level. So, I mean, this is not part of working set, right? AWE is in other way. We have something called locked pages in memory. Locked pages in memory for you to understand, right? So lock pages in memory model, we call it as a AWE. And if you remember 2000, I mean Windows 32-bit following this one, AWE memory allocation, right? And when a process references pageable memory that is not currently in the working set, a page fault occurs, right? So this page fault we already discussed. If the memory is not in the working set, let's say the working set has removed, the memory in the working set has removed, and it went to either a standby list or standby. For you to understand this working set also, there is some limit. Let's say, for example, working set is 30 GB. And if 50 GB is 50% is reached, or 50 to 60% is reached, whatever memory we have in the working set will be trimmed. And it will be placed into the internal memory area. This is also in the physical RAM only, but we are just clearing up some amount of memory in the working set. but it will be still available in the RAM itself, is called as a standby, right? So those pages will whenever it needs, this application needs these pages, it will read from this standby and it will again keep it in the working set. This is what we call it as a soft page fault, right? So if there is a memory pressure, and these pages will be removed from the memory and it will be placed into the page file page file, right? Whenever we need that memory, then it has to read through the page file. We call it as a hard page fault, right? So any questions or any point that you have not clear or not understanding? So these are all so understandable. Kiran, I cannot hear you, your voice is breaking. Not clear. Okay, so yeah, so this is working set. So mostly so I will stop here and we will connect tomorrow, so that I will explain that so the memory area, memory part, and so other memory models that we have, conventional log pages and lodge pages, and how that works, and then memory buffer pool and all, we will explain that